Okay, in this screencast we're going to practice using the equation of speed to make a few calculations. Talk a little bit about how you can help yourself as you go through that. We're using speed is equal to the change in distance. In this case we're going to assume a one-line motion. So on our data card we actually write it as delta x over delta t. So change in distance over change in time. Now, as a practice, as you're going through and reading some of this material, sometimes it is helpful to go ahead and mark out some of the values that you have and figure out what they are. In this process of trying to use a helicopter to measure speeders, they marked out widths that were 1/10 of a mile apart. That's a delta x in this case. And then they measured, in our specific case, it took 7.2 seconds to travel. Now, again, if you use different color highlighters, you can mark your variables in different colors. So this is the delta x, and this is the delta t. Okay, now the first question is actually more of a conversion of units. They have the time as 7.2 seconds. We want to convert that into hours. So we're going to multiply that by a fraction that's equal to 1. And the first part of that fraction, we're going to get rid of the seconds and turn it into minutes first. There's 1 minute has 60 seconds in it. Now this is a fraction, so these values here, these units, cancel out just like they would in any fraction. So it's now 7.2 divided by 60 are the number of minutes that it takes. Now if we still need hours, so now if we multiply that by the fact that there are in every single hour there is 60 minutes, we'll get these minutes to cancel out, and now we have our time in hours. So that method's called picket fence. You always multiply by fractions that are equal to 1. The ratio of the top to the bottom cancels out, equals to 1. Now, so that means it's going to be 0.002 of an hour for that tiny amount of 7.2 seconds. Okay, so now we want the speed. Well, it's delta x divided by delta t. We're trying to measure it against the speed limit in the miles per hour. So we're going to use 1/10 of a mile. And we're going to divide that by the time of 0.002 hours. Now, mathematically, 1/10 is 0.1. 0.1 divided by 0.002 gives us a speed of 50 miles per hour. Okay, now that may or may not be speeding based on where they marked it out. That might be okay, or it might be over the local speed limit. Typically, if it's a highway, it's probably okay. Okay, now we're talking about a train. Some of the fastest trains in the world actually magnetically levitated above the track. This fastest train travels about 155 miles in half an hour. So 155 miles would be our distance, and then half an hour would be our time. Now that's 30 minutes depending on what we want. Now in this case we're asked for the speed in miles per hour. So we already have miles, and we already have hours, we have delta x, we have delta t. So it's just a question of speed is equal to delta x over delta t, that's a delta, not a funny symbol, equals 155 miles, and in half an hour, which is 0.5 of an hour. 155 divided by 0.5 is going to give us 310 mph, miles per hour. So that's, faster than most small aircraft fly, propeller aircraft. That's a pretty good speed for a train. Now, just a little while ago, there was a higher altitude drop than the one mentioned here, but back in 1960, a record that held for a long time was the fastest falling average speed. Now, in this case, he fell 19.5 miles, and then he did that in at an average speed of 254 miles per hour. Now, 19.5 miles, that's the delta x. Now, even though they're falling, and we would often think of vertical as y, all we need is along one dimension. We can turn our one dimension any direction we want. So delta x in this case will be a fall. And then in the green, I've marked out the, this is actually the speed of the person on average. So I'm going to put a bar across the top of that to say it's not how fast he was going at the beginning, it's not how fast he may have been going at the end, but it was on average the speed he was falling with. Now we know that speed is equal to the delta x divided by the delta t. So if I want to solve this for delta t, I'm going to multiply both sides by delta t and then divide by v. So I'm going to end up with delta t is equal to delta x over v. Essentially, these two have just switched places when you do the algebra. 19.5 miles divided by 254 miles in every hour tells us that his trip would take about 0.077 hours, which is roughly about 4.6, a little bit more than 4.5 minutes. So he fell all that way in a pretty short period of time. He was moving pretty fast. Okay, we go from a big fall to just a small little hummingbird. Okay, so now this is an example where marking out your variables could be very helpful because there's a lot of different data in here. We just need certain parts of it for our particular solution. In the end, we are being asked to figure out how far the trip was across the Gulf of Mexico. So we're actually being asked for how far, which is delta x. Now, during the Gulf of Mexico part, it's not a 2,000-mile journey across the Gulf of Mexico, but it takes them 18 hours of time to go across the Gulf of Mexico. Now, on average, they can manage a speed of 28 miles per hour. That's average speed. Of course, sometimes they'll be going faster, sometimes a little bit slower. Certainly depends on which way the wind is blowing. That might help them or hurt them. But on average, it's 28 miles per hour. So now I have other data in there, but I don't really need it all. These are the parts I need. This is my delta. This is my V, not delta, my velocity, my average speed. So I'll put a bar over top of that. 18 hours, that's my delta t, and then we're looking for delta x. We don't yet know how much that is. Now, the base equation is v is equal to delta x over delta t. If I'm going to solve that for x, I'm just going to multiply both sides by delta t. So I'm going to have delta x is equal to v times delta t. Now, in this case, the average speed is 28 miles per hour. And the time period is 18 hours. Now, when you multiply that, notice that the hours here and the hours here cancel out, leaving you with a unit of miles. 28 times 18 is about 500, a little bit more than 500 miles across the Gulf of Mexico for their trip. Okay, so this gives you an idea of how you can use the speed equation to solve for distance, average speed, time it takes to make a trip. This situation is one where you might actually use when you're trying to get from, you have to be at a certain place at a certain time and you're going to drive. You can use this equation to actually get an idea of just how much time you need to leave yourself to get there. Okay, so that finishes this entire guide sheet at this point in time, and we'll be ready to move on to our next step.